Welcome back to the Simple C++ game series, where we make a simple game in C++ using X11 for the purpose of learning how to program. So last time we made ghosts that if you hit them, you die and the game ends. And we have food that if you eat all the food, you'll win. So now what we need is the ghosts to move on their own so that we have some kind of a challenge. All right, so let's say we do that. So the first thing we need to do is have the ghosts move in a random direction. We're not going to give them any sort of smarts. We're just going to have them randomly move in random directions. So what we're going to do is we're going to have some kind of a timer basically that will track the last time the ghost moved, and then after it's been a certain amount of time, then the timer will expire and it'll be time to move again, and the ghost will move in a random direction. Up, down, left, or right. So what we'll do is we'll have a function to move the ghosts first. We'll get that working, and then we'll add a timer to it. So first off, how do we make the ghost move in a random direction? Well, there's probably a lot of ways you could do this. An easy way to do it is just to get a random number, and we'll call it direction. Now let's just spell it out. Direction equals some random number, mod 4, so it'll be between 0 and 3. And if it's 0, then we'll move up. No, let's just go ahead and do it. So we'll move position dot y. We'll move it up 10. We should probably give it some distance, so we'll do that. So we'll say we'll make it a constant because we don't intend to change it. Oh, and I guess I didn't mention it. I think I've been using Vim. This is in CLion. It's an integrated development environment. You could use Visual Studio if you're on Windows, or CodeBlocks, or Eclipse, or NetBeans. There's a bunch of them out there. I use CLion, so you could duplicate a line by hitting Control-D. If it's 0, we'll move up. If it's 2, if it's 1, we'll move down. If it's 2, we'll move to the left. And if it's 3, we'll move to the right. And then we should be good to go. We just need to call move when we do something. So how about when we hit a key on the keyboard? Maybe we could use the space bar. So we'll loop through all the ghosts and we'll move all of them. If we hit the space bar, then all the ghosts will move some random direction, which is different for each ghost. Let's see if that works. Okay, so I can move, and if I hit space bar, nothing moved. Ah, they moved that time. Okay, so it looks like they're not moving because I didn't tell it to redraw when I hit the space bar. So what we need to do is just like we have here, game display redraw, we need to do the same thing after we move the ghosts. So we move, hit space bar, and they all move. Okay, very good. Now let's just hook that up to a timer and we'll be good to go. So for our timer, what we're gonna do is we're gonna save a time, and then every time we check, we'll see if the amount of time since the last time we moved is greater than some amount that we specify. And if it is, then we will move. Otherwise, we will stay put. So what we need is to decide if it's time to move. So we'll write a little function that asks, is it time to move? And then to decide if it's time to move, we need to take the current time, whatever that is, we haven't defined it yet, minus the time at last move. And if the difference is greater than some move time, then it's time to move. So we'll just return the logical result of that. Now we need to add some values in here. So we'll have a long for the time at last move, and we'll have a long for move time, and then we need this current time. So we're going to use the chrono library from the C++ standard library for this. So we'll include chrono. And what we want to do, I think what we want to do is create a little class to help us with the time management. So let's go to the top of our namespace and we'll add a time class. Okay, so what this time class is going to do is when you create it, it's going to store the time, and then every time you call some function in it, it'll give you time since it was created. So we can get some delta time, and it'll give us some time in whatever units we decide. We don't want programming mode, advanced mode. Okay, so if we think about this for just a minute, we could go with seconds or hours or milliseconds or microseconds or nanoseconds. I think we can go with nanoseconds, and here's why. Because a long is 2 to the 63rd power, which is pretty big. So if we divide that by a billion, that's how many seconds you can hold in the positive part of a long. Divide that by 3,600 seconds per hour, that's how many hours. Divided by 24, that's days. And 365, that's years. So we can hold 292 years worth of time in nanoseconds in a long. So that's plenty of time. So we'll just do nanoseconds. So we'll have our constructor here. We'll have some start time that's equal to the current time. And the way you get that in chrono is it's in the standard library in the chrono namespace. And there are different clocks. The one we want is the high resolution clock, and now gets us the current time. And we'll go ahead and copy that, I guess. This will be public. And then inside here, we'll create a private start variable, which is a std chrono high resolution clock. Time point is what the type is. Okay, and then the thing that we want to get is the time elapsed. So we'll return a long, let's call it elapsed. And we'll get the difference between the current time, which again is all that, minus the start time. And this gets saved into a duration. So I could use auto here, and it would automatically assign some type to it, but I actually want to choose a type because I want to return a long, and I want it in nanoseconds. So what we're going to do is we'll create a std chrono duration of type long in nanoseconds, and we'll call it elapsed, or elap, which is short for elapsed. And then we'll just return elap.count will give us the actual numeric value in nanoseconds. In nanoseconds as a long. So there's our little time class. So now we can go back to our ghost struct, and we'll add in here a time class. Well, let's call it time. Let's give all these. Shift F6 lets you refactor and rename. So we'll add a little underscore to say that it's a member variable. So this calls the constructor. So that'll set our current time, and then we just need to get the current time, which will be time elapsed. This is elapsed since the time class was created, which happens when the ghost class is created. So we get the current time minus the last time we moved, and if that's greater than the amount of time that we need in order to move, then we will move. Then it is time to move. So one thing we need to do is set the time at the last move when we move. So whenever we call the move function, we'll set time at last move to time elapsed. Maybe we shouldn't call it elapsed. Maybe we should call it time, since it's kind of telling us the current time. Okay. And one thing I like to do is give the units in here. So time at last move, that's in nanoseconds. So let's say so. Time since last move in nanoseconds, and this is move time also in nanoseconds, and this is time, well, we know that one's going to be in nanoseconds. It's a time class though, it's not a time itself. Let's go ahead and set this in the constructor. So we'll say that when we create it, that's going to be considered the first time that we moved. Don't really have to do that, but it's kind of nice to do that. And then we need to set the move time. So let's say for starters we just move every second, so that would be 1. So these apostrophes are just helpful to read the number. They're like commas, and C++ ignores them. So you can write it like this, or you can put separators in wherever you want. You can put as many as you want. It doesn't even matter. But just to make this more readable, we'll do that. So that's 1 billion nanoseconds, or 1 second. So now we want to ask somewhere, if it's time to move, then call the move function. Let's do it in update. We'll loop through all the ghosts and ask if it's time to move, and if it is, we'll move them. And if we move one of the ghosts, then we will redraw. So we'll start out with false, and if we move any of them at all, then we'll set it to true. And let's go get rid of where we had spacebar, and we'll comment this out. All right, so they should move every second, hopefully. I don't see them moving. Oh, they're moving, but they're not redrawing. Ah, I see. So what's going on here is a key has to have been pressed in order for us to call update. But we need to update the ghost position regardless of whether a key is pressed or not. So we should move the code that updates the ghost position into the main loop instead of doing it only when a key is pressed. So let's go into update. We actually need to put this somewhere else. Maybe we'll make a function for that. All right, still not moving. Update ghosts. We call update ghosts when we call handle event. I see. This only gets called when we get an event. So if there's no pending events, then we don't get any events. So that is still not the place to call it. We need to call it actually in run. Maybe this isn't the best place to do it. We'll have to rethink this. But for now, we'll put it in there. Now they're moving. All right, so that's a little slow. Maybe we'll make them move a little faster. So instead of every second, let's make them move every quarter of a second. There we go. And if we run into one, we die. The next thing we need to do is add a message when the game is over to say whether we won or lost. This means showing some text in the window. Right now we have is running, which means if the program is running or if it's time to exit. And within there, we need to know if the game is over or not. Once the game is over, we'll want to know if the game was won or lost, so we know which message to show. Inside the game class, we'll want two more booleans. We've got game over, and we'll have game one. Game one, yeah. So we'll default to that the game is not over and that the game has not been won. All right, so in our run function, we're going to update the ghosts. We only need to do that if the game is not over. Then we'll continue to get events whether the game's over or not. And when we handle events, is player within bounds. We actually only care if the player is within bounds if the game is running. So we'll check and see if the game is not over. In this case, we do not want to exit the game if they go out of bounds, so we'll get rid of that. So we'll just delete it. Can leave that statement in there for right now. Draw. Yeah, we can continue to do that if the game is over. And the ghosts and the player. So we'll draw everything if the game's over. On the key presses, though, it doesn't make sense to move the player. So we need to say if the game is not won, or if it's not over, then we'll do all of this. And then update. Okay, so instead of is running, we're actually going to say game over is then true. And game one is true if you've eaten all the food. If we run into any of the ghosts, then the game will be over and we will have lost. Okay, and then let's make the spacebar reset the game. So if we hit the spacebar and the game is over, then we'll reset the game, which means we'll reposition the player at the start position, create brand new food and ghosts, and set game over and game one back to false. Okay, let's see where that gets us. All right, so we're playing, and if we run into a ghost, it says you lose. And if we hit the spacebar, it reset the game. Very good. We can eat food. Let's see if we can get all these. Okay, the game ended and spacebar resets. Okay, so that worked. Now we just need to write a message. We can go ahead and get rid of this now. This should really go into a function because this little block of code does something useful. So let's make that more clear by putting it into a function with a meaningful name. Okay. Yeah, we can put this on one line. Maybe that's a little ugly. That's what we've been doing. It's short enough, it's readable. Okay, so the last thing we need to do is write some text on the screen when the game is over. There's a function to write text in X11, XDrawString. So we give it a display, a drawable, which will be our window, graphics context, the position, XY of the string itself, and the length of the string. This string here is a char pointer. The pointer gets us the address in memory of the first character, but we don't know how long it is. So that length there tells the function how many characters there are in the string, how many letters. First, let's write a function that lets us draw a string from outside of game display. We'll add it to the game display class, and then we'll call it when the game is won or lost. We'll give it a XY position, and let's give it a const stood string ref because we're not going to change it inside the function drawText. And drawText is also a const function because it doesn't change any of our member variables. So we'll put it right after getGeometry because that's the order they're declared in the class to keep things organized. DrawString. Give it display. And then we give it a window. And Control P tells us the arguments. We need a graphics context, which will be our default graphics to context with display and a screen. And then we'll give it X and Y and the string. And since this is a char pointer, we give it a C string, and we'll give it the length, which is just size. Now when we win or lose, we will set the string. We're gonna have to draw that when the game is won. So maybe what we do is draw player is called by draw. Okay, so we'll make another class called draw message. If the game is won, then we'll draw the right message. If it's lost, then we'll draw the you lose message. All right, so we have draw all ghosts. We'll add draw message or messages, message. Draw message, messages, draw message. Let's call draw message. And then we'll go after draw all ghosts. If the game's not over, we're just gonna get out of this function right away. We won't even continue executing any of this code. Otherwise, we continue and we ask if the game is won. And if it is, then we'll write you win. And if it's not, then we'll write you lose. And it'll stay there until player presses the space bar. See if that works. All right, let's go die. There's our text, you lose. It's a little small, so we need to make it bigger. So changing the font size in X11 is actually surprisingly challenging. So we're not gonna do that. What we need to do is just add a message to press a space bar to restart. So let's do that. Great. Now, one other thing is if we go out of bounds, you see it says game over, you lose, but it's not actually making us lose, so we need to change that. So here we check if the player's out of bounds. When the player's out of bounds, if it's not over, then we want to set game over to true. And of course, game one to false. That should be it. Very good, so we got out of bounds. And now if we hit them, and lastly, if we are able to get all the food. And we win. All right, so that's it. That's the whole thing. You can see how you could go on to collect points for the food that you gather. You could make the ghosts go faster. You could make them chase you by detecting your distance to them. There's a lot you could do with this. But this is a good start, so we'll call this one complete.